Okay, so yeah, so okay, we've kind of established this idea of taking a function, and as long as it's written something like this, we should be able to differentiate it. So for example, okay, you might get given something like, I don't know, 3x to the power of 7. Can anybody tell me what this would be if I differentiate it?
2x to the power of 7?
Yep.
21x to the power of 6.
Good, 21x to the power of 6, okay? So that's fine, you just bring the power down, reduce the power by 1, fine, okay? Can I please ask you as well, make sure you distinguish between y and this, okay? So do not write this down, which I have seen people write in the past. So you say, oh, okay, the question is y equals 3x to the power of 7. Then if I differentiate that, that becomes 21x to the power of 6. What's wrong with that?
It's still y.
Exactly. You see here, I've carried on the y equals, so the equals from the last line. That is equal to that. That's definitely not equal to that. Okay, so please, please, please make sure you always show me I'm differentiating now. Write dy by dx. Okay, what if I write something like this down then? Another thing which you might see. Y equals 7x to the power of 4 minus 12x to the power of 3. How would I differentiate that?
7 times 4.
Yeah.
28x to the power of 3.
So
Minus 36x to the power of 2.
perfect. So you're happy here. All you do is just treat that as one term, that as another term, differentiate each thing separately. Okay, what about something like this then? Y equals 4 over x.
4x power of negative 1, so it's...
Okay, so pause for a second. What have you done there, just in case people missed it?
We changed it, we made it a negative sign, so we put it up.
Good, so you rewrote this. Why did you rewrite it like this?
Because so it can be easier for us to do.
You had to make it look like this. If I just showed you that, you're like, I can't do anything with that because it doesn't look like it. Okay, so you had to rewrite it using the laws of indices. Good. Then you differentiate it. What do you get?
The negative 4x power of negative 2.
Yeah. Now, are you going to leave your answer like that?
Why wouldn't we? Dx, we need to write dx, right?
Oh no, so dy by dx equals that. But, and this is what I always say to people, always leave it in the same form that you got given it in. So because I gave it to you without any negative powers, because I gave it to you as fractions, you have to leave your answer in the same form.
Oh, so 4 over x power of 2.
Good. So that's a good rule of thumb. Always leave it in the same form that you got given it in. Gave it to you with fractions, leave your answer in fractions. Thank you. Yep, good. Okay, what about then something like this? Good, so you say x to the power of 4 over 3, you know that, it's fine. Then what sort of do with a dy by dx equal?
4 divided by 3x minus 1, 2.
Yeah, 4/3 minus 1 is 1/3. Yeah, are you going to leave your answer like that? No, how am I going to leave it? Cube root, yeah. I can see what you're doing. Yeah, fine. Cube root x like that. Okay. So remember, all I'm doing here is I'm saying, here's my function, here is my gradient function. Okay, here's my gradient function. So now, each of these, if I gave you that and I said, find the gradient at x equals 1, you could then just stick x equals 1 in there, and you could find it's at 21. Okay. Or for example, here, if I said find the gradient to this curve, y equals the cube root of x to the power 4 at x equals 8, stick x equals 8 into your gradient function. So that would be